Hey folks, it's Rob Flux here with another Sunday session, and today we are continuing our series on prefab construction, and we're going to be talking all about architecture and design and some of the things that we need to do in order to make sure that we're, designing correctly. What is called design for manufactured assembly. In order to do that, I've got a very special guest, Christian Skou from CSArchitects or CSArchitects. Christian, Danish background, you've been doing modular forever, mate. Tell us a little, because in Europe, you guys have been building modular since the dawn of time almost. Tell us a little bit about your background and how long you've been doing this.
Well, I graduated in 1977, and my thesis was actually prefab modular construction in multi-level, what we call 12 stories here in Australia. And since then, I was doing some short-term accommodation all the way through Germany for Accor hotel accommodation. They're still standing, so you can still see them if you're driving up through Germany. And then I came to Australia in 81, and then the whole of the issue of modular construction was a hard one to sort of keep going and continue with, because Australia at the time did not really have the interest in modular construction. But it's now turned around, and that's all what I'm doing. And I encourage everyone to consider prefab modular construction. Stay away from traditional construction. You get a better quality, better design, faster delivery. So prefab modular construction, that's the way forward.
Well, it's absolutely the future of construction. And I think there's a number of things why it's better. One, it's built in a controlled environment, and which means that you can be more efficient, more effective, higher quality build. It means less time on site, which lowers your holding costs, less wastage. There's so many benefits to prefab modular, it's not funny. Lots of different ways to actually do it, but it all comes down to the very thing that we're talking about today, which is the design, right? So if we are not designing for modular assembly in the first place, or what is known as DFMA, it doesn't give our builders any choice in what they can do.
No, that's correct. I think I say to all my clients when they come and say me, how do you want this project delivered? Traditional construction or prefab modular construction? Because that decision needs to be made up front. So you design, as you rightly said, DFMA, and I put the little D at the end because you've got to be able to dismantle it at the later date. So, but that all hangs together. So make a decision up front. Design for modular or traditional. Very important.
If it's designed for modular, it doesn't preclude a traditional stick build. It obviously has some certain parameters that we're going to be talking about with regards to how it's done, but it doesn't preclude it. So at minimum, giving that design to your builder gives them a choice to say, well, are we going to go down a traditional construction approach, or are we going to go down a prefab modular approach?
Absolutely.
But if you design for a custom build, then the builder has no choice.
That's right. I always say, if you design, no, let me go back. If you get a good architect, he will always provide a good design. It's simple, it's functional and all that, and it can be delivered as prefab modular construction. But if you go the other way, letting a builder come up with his design, you can't convert it. But if you decide down the track, if you have a design for modular construction, if you design later date, let the builder do it. He can very simply construct that and follow that design. You can't go the other way.
Yeah, absolutely. Which means that the most important thing as a developer, your job, folks, you're controlling the outcome of your entire project. Every consultant that you engage along the way, they are going to do as you instruct them. If you instruct them to design for modular in the first place, then you have pathways and options.
Yes.
If you don't instruct them, then they're going to keep doing things the traditional way that they have always done it forever and a day. So the very first thing you want to be asking your architect is, can they or do they have any experience with designing for modular assembly? Now, right now, modular assembly, modular construction methods only make up about 10% of all construction happening in the country. Whereas in places like Sweden, I think you said before, about 80% of 80% of every home, and we're talking about detached homes, 80% is built in a factory and then assembled on site.
Yeah.
So we're a long way behind, folks. But that said, it won't take a lot for the industry to change if we, as developers, start asking for the right thing in the first place. Now, the first architect you come across might not know what you're talking about, or they might be resistant to do it. That's okay. There's plenty of other architects out there that will. Okay, but when 3 or 4 people ask them for DFMA, then all of a sudden they're going to start to realize that is where the industry has pivoted to. And there's always people like Christian, I'm sure, who will take on the job if you can't find an architect in your area. But mate, for an architect who's not done DFMA, is it a hard process to learn?
No, it's not. Saying that, I mean, I'm working with a number of different architects, and I got one, thinking about one in particular now. They have never done modular construction before, and we started to do it. We did the planning. I did the overall design, handed it out to the architect, and they took it from there. And me basically guiding the design. They're very, very happy. They have learned a lot. I don't think they will ever walk away from a modular opportunity again. They think it's fantastic. They learned a lot. So yes, you can learn it. Absolutely, Rob. It's a simple process. Architects, I like to say that architects have been educated in solving problems and solving issues. So they look at an issue, they come up with a solution. And if it's a modular solution they're looking for, they can come up with it. They might need some help, but they'll get there.
Yeah. So, and what I'm hearing is that as they transition, the architects are actually starting to learn. They're engaging with people like yourselves in the back end to just go, right, what are the things that we need to consider, get the baseline design right, and then they can add their architectural flair to, I guess, the baseline, let's just say the frame of the house, for want of a better word.
Often developers are engaging me as their advisor, if you like. That means helping them to select consultants, architects, engineers, certifiers, etc., but also setting the guidelines for the design, making sure that it can actually be delivered as prefab modular construction.
Absolutely. Now, everything can be modularized in some way, shape, or form, but I guess the scalability of the projects, the more custom and the more bespoke your home is, the more expensive that's going to be as a one-off construct.
Correct.
If we can start to, as an industry, start to standardize in what is referred to as a kit of parts, where we start to have common sizes for things like bathrooms and common sizes for kitchens and common sizes for different elements, we can use them like Lego bricks and kind of stick them together and come up with all sorts of architectural designs. Now, Christian, you mentioned one that you've worked on with a design you're calling the spine of the house, where you can plug and play effectively the different elements into the house.
Yeah, that's correct. I mean, all the wet zones were in a volumetric design, delivered to site, connected to site, and then you can go to town with all different lean-tos, panelized, kit of parts, you name it. I mean, there are some very good kit of parts manufacturer in Australia. I mean, there's a company called GTT, Pete Morrison. He has a whole new setup of kit of parts, really worth looking into. So it's coming. And I love to see you can do it as modularized. So you can have a panelized wall panel, if you like. You can 1200, you can have a window, you can have a door and a window. It still sits to the 1200, and you can modularize the house. You can go down to the modules of 300, 600, 900, 1200. If you're adding any of those modules together, you can do anything.
Yeah, so start to think about, I guess, standard window sizes, standard wall lengths, and incremental elements where I guess the majority of the companies that I'm coming across are saying, well, if it's a 300 mil increment or 30 centimeters, is it a 30 centimeter wall, 60 centimeter, 90 centimeter, 1200, 1500? If you start to build in those increments, then it's a lot easier to then, I guess, start to plug other interfaces together.
That's right. Absolutely. And the good thing is, it's easy to expand to that type of house. If you have all these individual modules of 3, 6, 9, 12, perfect. Then you have 24 before you know it, 2 times 1200. If you want to expand that or put an angle on the house, you just dismantle these modules or these panels, and you expand it this way, and you use modules again, and you can order those modules and get them delivered.
Yeah. Now, when we were speaking to Damien Crow from Prefab Oz the other day, and we talked about, so for anyone who didn't watch that episode, go back and watch that episode. But we were talking about the 4 different methodologies. We've got panelized, we've got kit of parts, we've got volumetric, and we've got additive, so 3D printing.
Right. 3D printing.
And then we've really got then the hybrid of using those. And you're talking about, we're talking about, well, you could use volumetric for, in your instance, the spine of the house, but you might use panelized for other elements of the house, which then means you can get all of the complicated wet zones and that sort of thing done in a very, very fast assembly. And the panelized system only goes up in a couple of days. So then it's just really finishing off the home.
That's right. But you can also use the panels for filling of the volumetric. So you've got the steel frame, and all your walls could be panelized. The floors could be panelized. The ceiling could be panelized. So coming back to the panelized system, I'm a big fan of using different panelized systems as infill for volumetrics, as well as in a hybrid setting.
Yeah. And for anyone who didn't watch that episode with Damien, when we're talking about panelized, we're taking the concept of a frame, and so you could be a wooden frame or a steel frame, but we're actually then adding value to that frame, and we're actually putting the cladding on both sides. So if it's an external wall, then it would be exterior cladding plus insulation and waterproofing, and any electricals, and then the plasterboard on the inside. If it's an internal I guess panel, then it might be plasterboard on both sides and all the electrical and plumbing that's actually sitting inside the panel. But all of that's manufactured in the factory and then assembled on site.
Yeah, that's right. It's a straightforward process, really.
And so the whole concept here is to think of this like Lego, okay? And once you understand that the interface on a Lego brick is exactly the same, whether you're using a 2-tile Lego brick or a 12-tile Lego brick, once you start to recognize that, then you can build an 800-pound gorilla, or you can build the Eiffel Tower, or you can build a racing car, or they're all completely customizable, but you're using standard parts to get there.
That's right. And it's based on DFMA. I mean, you mentioned the racing car. That is a typical and very good example of DFMA, isn't it? All these little components all goes together and fits in, and it only fits in there. And they're all being manufactured somewhere else.
Yeah, well, and in that instance, a racing car or even a normal car, it's probably manufactured in 100 different plants, the parts then brought together and assembled in the actual car factory. It's really just taking that whole manufacturing process and saying, well, why aren't we doing that in something that's much simpler to construct, being a house?
We have used the automobile manufacturing process as a very good example of manufacturing houses. And you would hear from Damien Crow that he would have used that example a number of times. And a lot of people, from when they shut down the automobile industry in Adelaide and other places, the people from that industry got transferred straight into the manufacturing industry for houses.
Yeah, there's a couple of factories in particular in Melbourne that I'm aware of that, their lead foreman and that sort of thing have come directly from the car manufacturing industry. So, so absolutely. So, in putting this together, like, I guess first step one, getting the architect on board. What are some of the potential challenges that an architect might push back on if they've not got this experience?
Well, there's they will probably go outside the recommended width and the length and the height we recommend. That's if we're talking volumetrics. I mean, volumetrics relies on a maximum width, purely for transportation on the roads and the overhead bridges. So we got to be mindful about getting the product from the factory to the site. If you're talking panelized system, it's a lot different, isn't it? Because it's a flat pack, go back on a semi-trailer, and you erect it on site. If you're talking to the architects, they need to understand the process of designing. I mean, I kept saying you've got to think modularized design, and as soon as they start thinking the process of modularizing design, then I think they're halfway there, and it's good. Then there's hardly any limitation there. It's open slather. You can go whatever. Take it as a challenge rather than a restriction. You can provide any design, any good design.
You mentioned volumetric there, and some people that didn't watch our previous episode, I'll just explain volumetric. Volumetric is where you, instead of having just the panel, everything's actually stood up inside, I guess, a structural three-dimensional shape, and usually that's steel reinforced, but it can also be timber as well. But the three-dimensional cube can then be fully fitted out, so it can have all of the bathrooms, the kitchens, the plaster, the flooring, everything actually built. So the house, once it's plonked down on the ground, is finished, right? And so from a volumetric perspective, you can get 3 or 4 of these, modules and plug them together to then, in literally hours, have a fully assembled house.
And they come with the roof, if that's what you want. So yes, you're right. I mean, we can install a 3-4 bedroom home within a day on site.
And for anyone who's not seen this before, this is, a TV series that Prefab Oz initiated called Epic Builds. So epicbuilds.tv. If you want to go to Epic Builds, you can actually see a whole bunch of these volumetric type homes actually installed. You can also see some panelized ones done as well, just so you can see how fast we're actually constructing. Now, in the instance of that particular TV show, they issued a 90-day challenge to say from starting of manufacturing to finishing on site, 90 days from start to finish. And there wasn't a single project that didn't hit that 90 days. And the majority of them were under 45 from start to finish.
Yeah, that's a normal goal. I mean, the beauty of it there is you're working on 2 sides. You're preparing the site out in the real world, as well as you're doing your volumetrics or the manufacturing in the factory. And when the site is ready to take it, the module is ready to go in, and it gets installed, connected up. It's a plug and play system.
Absolutely. And so the constraints to be thinking about from an architect's perspective, if you're going to be considering something like volumetric, it's how do you freight that to site? And so you've got to start to think about, well, from the factory to the site itself, what is the road network that it's actually going to be traveling across? Is it a single lane road? Is it a double lane road? Are you going under any bridges? What are the challenges you've got to start to think about, from how wide the box is, how high the box is, and that might change the dimensions of the modules that you actually put together to actually ensure that I guess there's an easy transport mechanism to actually get there. And also, if there's things like power lines and that sort of thing to actually crane it in sight. Otherwise, they may instead move towards the more panelized approach, where you don't need all of that those constraints, because you're effectively flat packing a house.
These logistic companies, they offer a desktop analysis of your transportation. So if you decide that you want to go volumetrics, and you have selected a supply company, and the supply company would be in one location, and you want to transfer to another location, they do a desktop study, and they take they work out the roads and the transportation to it. They check all the bridges, as you mentioned, the power lines, the roundabouts and things, and then they give you the right location. And so it's done before you actually commit to the supply company. I've been in a situation where after we had done the analysis, we recommended not to go volumetrics, but we went for panelized systems. So volumetric is not the answer to all questions. I mean, there's horses for courses. So you just got to look at it. Comes down to the design. Not all design suits volumetrics. Some is better in panelized systems or a combination. So
yeah, what I would say, site specifically, which technology is the right one. For our audience, I'm going to say the majority of it is going to be a choice between panelized and volumetric, or a hybrid of the two. Now, if you're using a panelized type approach, then you're not going to have any of the real constraints from a I guess a transport perspective, and you're going to be able to stand up the shell of a house in 2 to 3 days at watertight, and so then it's up to the builder to then fit out the shell of the home with I guess the bathroom and the kitchen and the cabinetry and the flooring and that sort of thing. But it means that they can get trades to turn up on site, and the trades can be there from start to finish. They're not there for 2 or 3 hours and then having to go out to another site and come back waiting for their turn to do stuff. But they can actually stay on site, and the sequencing of the project is vastly improved. So that's I'm going to say that will work in almost every instance. Then the volumetric.
To sort of go a little bit against you there, I think if we're going volumetrics, we're trying to minimize the number of skilled labor to keep the cost down. We can manufacture a volumetric or design based on volumetric designs with less people on site. I can deliver them faster than you can with a panelized system, but it's not all the design which suits the volumetric. So that's why I said before, they're horses for courses, and don't just get, don't put your blinkers on and don't say, this is what I want. There are different options to skin the cat. And it could be a combination.
The good news is we weren't disagreeing. I just hadn't gotten to my point. So that's okay. What I was trying to say there, Christian, was that panelized is going to work in almost every instance, but it's not necessarily the best outcome. Volumetric is the fastest way to actually assemble, and all the points that you actually touch to, but volumetric won't work in every instance.
No, that's
so
correct.
You've got to be, so volumetric is the, whilst it might be your preferred outcome, it has some constraints that you need to start to look at first and may not necessarily apply. Panelized, I'm going to say, will work in 95% of all instances, and so is the de facto if you can't get volumetric in place.
That's right. I mean, volumetric design is very good when you have a nice, pristine site, undulated, steep sites, whatever, and the client comes and say, well, what's the best solution here? I would 9 out of 10 times say, well, volumetrics is a good solution here. Let's start with that. You don't need to touch the ground. You don't need to create slip planes. You can basically put it on posts and deliver that volumetric design.
So at the moment, I guess in trying to think this through, your architect is going to be designing for it. Getting the actual manufacturer to construct this, a lot of people have a preconceived idea that there is not many manufacturers in Australia at the moment. In talking to Damien at Prefab Oz, there's somewhere in the vicinity of 1,100 different manufacturers scattered across Australia in different verticals within here. So I'm going to comfortably say that the industry is maturing at a very, very rapid pace, and a lot of these companies are hiding in plain sight, waiting for people like ourselves to actually go and give them projects.
That's correct. It is maturing. It's maturing fast. You just got to be very careful. A bit of due diligence and scrutinize these manufacturers is very, very important. And that's one of my jobs. For instance, when a client comes to me and sort of say, who should we use, I can recommend, and I'm happy to look at some manufacturer, but I like to go and see them. I like to see their factory. I want to really ask them certain questions and say, how do you do this and this and this? They need to come up with a production program. I need to see their production facilities. Some manufacturers, they are still doing it in the sheds in the backyard. They need to get a proper manufacturing facility up and running. But you're absolutely right. It's maturing very quickly at the moment.
And I would say that it's fairly comfortable to say that whatever state you're based, there are going to be local manufacturers that are going to be able to deal with what it is that you're trying to achieve.
Absolutely.
Now, in trying to qualify your project, the very things that Christian's actually talking about, the scale of your project may dictate the manufacturer that you're dealing with. Some manufacturers are only wanting to deal with very large quantity orders. So if you're building 100 homes, then they're really tooled up to deal with that. Other manufacturers are tooled up for the small scale bespoke type homes. And so you're going to have a look around depending upon your project to find the manufacturer that is actually going to suit. But then there's the hybrid that I think, which is really where I want to start our industry to start to think about, which is, what if we were building small scale homes, but at a scale in our design and architecture? So what I mean by that is, how do we have patterns of homes where we might have 20 or 30 patterns that are able to be, I guess, printed on a much smaller scale in the smaller organizations, but we can scale that because that factory is potentially going to be doing your duplex and someone else's duplex and someone else's duplex all at the same time, which means that you're going to get the potential scale of a factory able to do 100 homes, but at the price point and the ability for you to roll it out, I guess, one project at a time.
What has happened here in the industry, and actually some of the governments, state governments, have been pushing that very hard. They're trying to standardize the design. So if you can imagine, we have a module, which, let's call it a bedroom module. We have a living module. We have a garage module. They come up with certain criteria. So if you have a master bedroom 4x4 and an ensuite and a walk-in robe, we can come up with a design which suits that particular module. And it can also have an office component, if you like to have that in the same module. So we can standardize the module designs. That means you can actually pick them out of a catalog and say, I like to have that module, and I'll have that module. I'll have it going with that particular module, and you can combine your overall layout. So it's still modularized, and it's still manufactured homes, and it's a standardized design. So that's nothing new in that. That's been going on since Second World War, when they're saying, okay, we got a sleeping quarter, we got the bedroom quarter, we got the kitchen quarter. And you touched it on yourself, Rob, when you said bathroom pods. I mean, there are manufacturers around Australia, they're doing nothing else but manufacturing standard bathroom pods. You can order bathroom pods and put them in your home. And
yeah, but a bathroom only has a finite number of designs and a finite number of dimensions that it's actually going to come in. So by standardizing on that, we're going to know exactly, well, where does the water come in? Where does the sewer go out? How do we plug our services in? What are the interconnects between this module and the next module? If we can design that consistently, then we can get an off the shelf product. But even in that off the shelf product, again, off the catalog, we can say, well, is it going to be a round bowl or a square bowl? Is it going to be gold taps or silver taps? Is it going to be gray tiles or brown tiles? So even in the standardization, there is still customization so that no two homes are going to look the same, even though the elements that actually go within them probably are.
That's right. That's just finishes. You can pick your finishes, what you like. The structure and the plan and the layouts are the same.
So guys, girls, everyone out there, I guess in the PDN community, I really, really, really am going to encourage you to start to go, how do we start to standardize on these things? the more people that are starting to use the same kind of elements and the same modules, the more that we're going to get the manufacturing industry being able to produce these things on scale. And then when they're produced on scale, it's then going to, over time, lower the cost of the construction of these things. If we continually do bespoke designs every single time where my home is unique and Christian's home is unique, then we're going to continue to pay the very high construction costs that we're paying today. But over time, we want to start to bring these construction costs down, and that's the only way to start to do it.
We have a huge demand for affordable housing, as we all know.
Huge demand for just housing. Don't even worry about affordable housing.
No,
we're on target to be about 450,000 homes short of the housing accord at the moment, and so prefab is the only way. And this is something I really want the builders out there to actually start to embrace, because there's a perception that prefab being built in the factory means that the builder's role is kind of lost, okay, and that the builders aren't going to make money out of this process and those sorts of things. But still, there's a massive role for builders to actually play. There's the site preparation, there's the finishing off, there's when the modules come together and the panels come together, they still need finishing off and finishing trades and those sorts of things. But the ability to roll out many, many, many projects inside a 12-month period, rather than having a $5 million license and only building 5 homes a year because it takes you 12 months to do. Now you're going to be able to roll out maybe 50 homes a year, and you recycle that same $5 million license many, many times during that timeline. So your risk exposure goes down. Your cost, it goes down because you're in and out in the same market. You're buying materials and delivering them in such a short timeline. Your price variations are going to disappear because you're pretty much ordering it and installing it almost instantaneously. It's going to be a win-win-win for the industry. I think the housing community needs houses. We're going to get them out there faster. The builders are going to get more throughput, more productivity, more profitability, less risk. And from a developer's perspective, we're going to massively reduce our holding costs. And so that's going to improve the profitability of our projects. Even if right now we don't change the cost of construction, just the holding costs will make our deals more profitable. Over time, I think we're going to get discounts, but it's going to take time to get there. So Christian, with the volumetrics, we said some considerations on the dimensions. Let's go back to there. So from the transport side of things, we've got some common dimensions that we would actually work with in order to make sure that it fits on a truck and under a bridge in most instances. That means that we only have one pilot vehicle or sometimes no pilot vehicle on our projects.
That's correct. That's correct.
Right. So what's a typical module size to reduce the cost of that transport?
I normally say that we got to stick to modules below 4.5, 4.45. That means right down to the middle of the width. Then you only have one pilot, and the pilot comes with a logistic company anyway. If you go above that, you can do that, and the manufacturing company can manufacture them. That's not an issue at all. But you will have a police escort, and the police escort is adding considerable costs to a single home. If you're looking at a multi-level or a huge project delivered, then it's a small added cost to the overall project. But if you're looking at the mums and dads for the houses, I recommend that you stick to 4.45 as a maximum width, no higher than 4.8 in height, which is substantially. You can actually get a nice sloping ceiling, and it looks really good. And lengthwise, it's we're more flexible there, but 14, 15, 16 meters of long modules we can handle. But it will be determined by the logistic company when you commit to the module design and with the company. So
yeah, so
each of those, that's a good guideline.
Yeah, so whilst you can do bigger, like you said, the pilot vehicle needing police escorts, and if you're needing a police escort, it's almost certainly that they're going to be doing that at night as well. So then now you've actually got, I guess, the freight costs happening after hours, not during hours. So whilst it can be done and it shouldn't be precluded, it's an unnecessary cost if you can avoid it and design within that 4.5 space.
That's right. That's right.
But you can get some very, very creative outcomes in doing that. So getting a house, that's 9 meters wide is just putting 2 modules side by side.
That's right.
Getting a house that has a giant void when you walk inside the front door is just about putting 2 modules on top of each other, where there's no ceiling on the top of one module and there's no floor on the bottom of the other one, right? So we can get the same look and feel in most instances as you are in a standard home, and I think there's a perception that because we're bringing it in a box-like shaped structure, that everything is going to look boxy, right? But that's not truly the case, is it?
I can guarantee you that we can deliver houses which you would not be able to say at the end of the day that it's volumetrics or modules. There's no way. You can design that out. It's just a matter of understand what you deal with. And you could get some exceptionally houses. I mean, I mentioned to you the House of the Year this year, awarded by the Institute of Architects here in Queensland. The House of the Year right across Australia was a modular home delivered by a local modular supply company and designed by local architects here in Queensland. Absolutely fantastic.
Which just means that you shouldn't put any constraints on your preconceived ideas. Okay, there's no reason why you can't do it. As a matter of fact, there are particular things that you can do in a modular sense a lot more cost effectively than you could do in a traditional sense. So, for example, if you wanted to have a cantilever, I guess the top modules overhanging the bottom modules and actually creating an architectural space, that's actually much easier when we're talking modular than it would be if you actually did that in a traditional stick build.
Absolutely, because all the strength sits in the chassis, which is the floor structure of it, because of it's designed and engineered for transportation. And it doesn't matter if it comes from overseas, it's designed for transportation on a ship, or if designed for transportation on the road. Much, much, much stronger than a normal traditional built floor, so it can cantilever. You've got the strength. It's part of the design.
So you touched on overseas there. Now we've got 1,100 odd manufacturers here in Australia, but equally there's a whole bunch of manufacturers that are overseas, and particularly in parts of Asia and China and things like that. What are the constraints that we would need to consider if we wanted to bring them from overseas? Maybe we find a supplier that might be a little bit more cost effective, for example. What are the things that we want to consider there?
Well, they need to comply with the Australian code, the National Construction Code. All their plumbing and needs to be watermarked. All the electrical cabling switches need to be marked and be approved by the Australian industry and the certifier. So it needs to go through a rigorous certification process. It needs to meet the Australian standards. Otherwise, it will not be allowed into the country.
Absolutely.
So it be sent back.
And here's the thing, folks. Whilst that is the case, and absolutely we need to always be careful with doing that, the irony is that most of the materials that we're installing here in Australia that meet all of those certifications are actually manufactured in China anyway.
That's right.
And so in a lot of instances, you could actually be sourcing it directly from the actual manufacturer, directly to site, but it still needs to go through a sign-off process to make sure that it's been validated and tested on site.
Yeah, that's correct.
And I know, Christian, that was something that you said that your particular company, having done this many, many times, you actually have a process that as a service that you can actually do to make sure that if it is being imported.
We do have a service, and we are currently involved in a couple of projects where we put a team of consultants, structural engineers, services, hydraulic, electrical, mechanical, and a certifier together to certify, and they also go to the supply company or the manufacturing company in China or Vietnam or wherever that company sits to provide evidence to the certifier that it's being manufactured correctly and in accordance with the Australian standards. So that's a service we can provide, which is an interesting, and it guarantees good product, and it works well. I encourage actually Australian supply companies to have an alliance and a relationship going with some overseas supply companies. I think they can learn a lot. They can import components from China, Vietnam, or Singapore, whatever they come from, import components, bring it back into Australia, assembly them here in Australia, and it becomes an Australian product.
Yeah, I agreed. And whether it be a factory here in Australia, whether it be a factory overseas, I think the principles are the same. They're going through the same quality assurance processes in how they put it together.
Yeah.
They're effectively creating a digital twin of the home, I guess, in a computer before it actually gets made on site, and then it's validated at the end of the process that the design and what is delivered is exactly, as opposed to someone out on site with a handsaw, I guess, measuring it with a tape. And I don't know why those tapes have got a flexible end on them.
Margin, sort of give and take.
Yeah, there's a little bit of give and take in that, but it means it's, down to the millimeter accurate is really the outcome that you're actually going to get. So the quality, the time, the speed, no matter where it's actually manufactured, I think is going to get a much better outcome. But it's the speed. It's the speed that is the biggest saving. Right now, there's a whole bunch of myths around it saving, I guess, the cost of construct. I think at the moment you're pretty much on par from, whether you do a stick build or whether you do a factory build. But the timeline and the savings in the timeline are going to save you in holding costs, interest rates, land tax rates, all those sorts of things.
But you also got to think about, if you are manufacturing your home, you actually become a good neighbor. And I have an example here. If you are dealing with a existing retirement village, where you've got to expand an existing retirement village, I mean, isn't that nice? You can actually deliver the homes. There's no dust, there's no jackhammering, there's no concrete trucks, there's nothing. You become a good neighbor. There's nothing worse than living next to a building site. But here you can get them, dust-free, noise-free, delivered, which is
and fast. So and if anything, the neighbors come out and they ogle at everything actually being installed because it's going up so fast.
Yeah.
So it creates a conversation piece between you and your neighbors.
Absolutely.
Yeah. Some preconceived ideas about modular being boxy and things like that. We kind of touched on that, but inevitably, when the modules come together, there are going to be joins, and there's going to be, I guess, a couple of things to be considerate of. What are the things that you need to consider when bringing two modules together, whether they be two side by side or whether they be two vertical? What are the things to consider?
Well, if you bring two modules side by side, if you have a portion of a wall on one module and a portion of the wall, you will get double thickness for that portion of the wall. But it's completely closed off. You won't see it. And I guarantee very few people will notice it if they walk through the house. But there are some doubling up on the dimensions where you're putting them together. But you won't see it. I mean, if it's on the floor, if it's a timber floor, carpet tiles, they will just cover the floor. If it's in the ceiling, cover with plasterboard, so you won't notice that. External cladding, you would bring the two external claddings together, you won't see that either when it's all done. But it's the nature of the beast. You are bringing two modules together and two structures.
Yeah.
The same with the heights, the modular heights. But the good thing, and I keep saying it because people forget about it, is the acoustic benefits you get with that extra wall, being a vertical wall or a horizontal structure of the ceiling and the floor above. if you're using 2 modules, you won't have any annoying teenagers running around on the upper floor. You won't hear that downstairs because you've got more acoustic treatment to the floor and the same in the wall. Again, it's the nature of the structure. You've got more structure, more insulation. You've got more mass in those structures.
And they're physically not connected. The top and the bottom, the floor of the top and the ceiling of the bottom are not physically connected. So any vibration that happens on the floor doesn't transfer through. So you've got the thermal, sorry, not thermal mass, but you've got the mass of the actual insulation that sits in between. But you've also got the physical distancing and separation.
You actually, now you're touching on something which I really like. I mean, the multi-level. And that's where that really comes in. So a volumetric module sit on top of another one, but there's a neoprene sort of rubber thing which sits between that. So if someone drops you a teaspoon on the upper level, you won't hear it on the lower level. The stilettos will not go through to the lower level. You get a much better STC rating, from apartment to apartment or from floor to the lower level.
When we're starting to think about multi-res, whether it be duplex or townhouses and that sort of thing, bringing 2 houses together that are 2 modules side by side, the fireproofing in between is one that a lot of people would be concerned at. What are the things to consider there?
Well, there's a number of ways you can do it. I mean, some people will actually do it, will put a block wall up. I've always said, no, don't do that, because you're mixing the trades. You have a wet trade and you're dealing with the dry trade. You can easily do it with fire check and insulation in between those walls. So each module will come with that wall facing the other module, will have a fire check of the 90-minute fire rating, and the other module will come with a fire rating of 90-minute. So it will be added to the cladding in the factory, and they're just being put together. And that gives you the fire rating between the 2 walls. So the common wall is fire rated. The same principle, not quite, but the same principle is when you go vertically.
Very good. So anything that we've not covered here, Christian, that you think is something that from a burning perspective, everyone should really know when they're starting to think about designing for modular?
The first thing is you got to make up your own mind what way you want to go. If you said modular, you got to find the right consultants. And when you get the right consultants and you're prepared to join the journey to go on, you will be involved and it will be a fantastic journey. But first thing is you got to make the decision. Do you want to go traditional or you want to go modular? Asking me, there's no only one answer.
It's designed for modular all the way for me. It's the benefits far outweigh anything else. And whilst there is a learning curve that needs to occur, it's not an insurmountable learning curve.
No, it's not. And it's really good to see someone like Prefab Oz. They are really working very, very hard with the universities. I'm working as a mentor to the universities and to architectural students. So I know that the architects coming through the system now fully appreciates all the benefits of modular construction. It's nothing new. Modular has been around for almost hundreds of years.
Well, both the Chinese and the Romans were doing it thousands of years ago. So it's been around a very long period of time. But Europe on scale has been doing it for 40 to 50 years.
My dad, he was an architect and a builder. And I was, 6 years old when he did and delivered the first houses. He called it the 30-day house. And it was all done with big walls being delivered to site, closed up, 30 days, handed over the key.
Well, you said that your architecture degree was 1971 and your thesis was on prefab at the time?
77.
77. So that's a long time, folks. So I want everyone to really take away that whilst the industry is in its infancy in Australia, the technology is very, very mature. Okay. And so rolling out this, we've got a ton of different suppliers here in Australia. We've got suppliers that are overseas. what really needs to change, folks, is one, you as the developer need to start to ask for it. Okay, so ask your architect, design for modular assembly in the first place. You now have a design that you can then take to your builder, and you're going to ask your builder, hey, we've got this design that's capable of that. Would you be interested in coming on the journey with us in actually trying to build that? And if not, there are plenty of builders out there that actually can and will do that. So those two, bringing the architects on board and bringing the builders on board, I think will mean that in 2 years' time, the Australian industry won't be 10% of construction that is prefab. I think it's going to be closer to 50. I think we are going to change that fast, that the industry is at a tipping point right now. And I think we're going to change that fast.
That's correct.
Yeah. So, Christian, mate, been a fantastic conversation. Thank you very much for sharing your insights into this journey, and especially with the years of experience that you've got. Any passing words of wisdom you'd like to give our audience, mate?
No, I can't think of any, but what I'd like to say, when Second World War finished, 1945-46, US had all these soldiers out in the world. They had a massive, massive issue to rehousing when and bringing them back. One of the world's greatest architects, Walter Gropius, he went to US, he developed a modular system, and it was panelized system, and they developed thousands and thousands and thousands of those houses. That system, in principles, has not changed. That's how we do it today. So, commonly known in both US and UK, nothing's new.
Nothing's new. It's just rebranded and rebadged, and
that's right.
Calling it modern methods of construction is probably a little bit of a misnomer. It's just I guess Prefab Oz are preferring to call it smart construction, and I think that's probably the more intelligent way to actually look at it. Is how do we start to work, I guess, in a smarter way?
Yeah, there's so many examples of good designs on the web, and look them up. Give me a call.
Very good. So that said, Christian, thank you very much for your time today. Now, folks, if you are watching us here today, these YouTube channels are not the only way that you can actually engage with us. We actually run networking groups all the way around the country. We run them in Brisbane, Sydney, Melbourne, Adelaide, and Perth. You can physically attend every single one of them if you are local, or alternatively, you can live stream them no matter where you're located. So we run in the vicinity of 55 events per year, where we get industry experts just like Christian to come and talk about different issues, challenges, and problems that you actually have. Equally, we have members of our community sharing real deals, the good, the bad, and the ugly of a project. And we're going to start to be showcasing a number of prefab projects in the not too distant future on our stage. So come and watch this space. Christian, thank you very much for your time, mate. I'm going to say hope to see you at one of our upcoming meetups, mate.
Look forward to it.
See you, folks. Bye.
Bye.